The machine worked. That was the problem. In the late 1960s, inside a Soviet research institute, a room-sized computer processed economic data faster than the ministries that governed it. Magnetic tapes rotated behind glass panels. Punch cards stacked in gray trays. A printer fed continuous sheets of perforated paper across a metal bar, each line emerging in steady rhythm. Engineers stood quietly beside it. The machine was not dramatic. It did not glow. It did not speak. It calculated. Its purpose was administrative efficiency. The project was called OGAS, the National Automated System for Computation and Information Processing. It was proposed by cyberneticist Viktor Glashkov as a solution to a growing structural problem inside the Soviet economy. By the late 1960s, the planned economy had become increasingly complex. Thousands of enterprises reported to hundreds of ministries. Each ministry compiled summaries. Each summary traveled upward through paper channels before reaching central planners. The delay between production and evaluation could stretch for months. Corrections came too late. Bottlenecks multiplied. The idea behind OGAS was not ideological reform. It was computational acceleration. Instead of paperwork moving across offices, data would move electronically across a network of computer centers distributed throughout the Soviet Union. Factories would input production numbers directly. Regional nodes would aggregate them. A central system would optimize allocation and adjust quotas dynamically. It was presented as a tool to strengthen the planned economy. The early prototypes worked. Pilot systems processed regional statistics in hours instead of weeks. Error rates dropped. Inconsistencies surfaced. The machine began to reveal where reporting figures diverged from physical output. That was not its official purpose. But arithmetic has no preference. The machine worked too well. To understand why that mattered, it is necessary to understand how planning operated. A centrally planned economy depends on negotiated targets. Factories receive quotas based on prior performance. Managers adjust reports to maintain predictability. Ministries compile results in formats aligned with long-term plan objectives. 5-year plans rely on statistical continuity. Paper allowed elasticity. Numbers could be rounded. Shortfalls could be reclassified. Delays provided space for correction. OGAS altered the timing. When raw data entered a computational system directly, elasticity narrowed. If a steel plant reported output figures electronically, discrepancies became visible immediately. If transportation delays affected delivery, the network flagged the imbalance. If surplus inventory accumulated in one region while shortages appeared in another, the system suggested redistribution paths. The network model ran optimization simulations. It did not negotiate. It calculated. In internal demonstrations, engineers modeled a concrete production chain. A cable factory in Ukraine reported exceeding its quota by 4%. On paper, that meant success. But the motor assembly plant in Sverdlovsk reported delays in final production. The numbers did not immediately appear connected. The cable factory had fulfilled its target. The motor plant had missed its delivery window. OGAS cross-referenced specifications. The updated motor design required reinforced wiring. The cables produced in excess were based on the previous standard. They were technically compliant with the quota. They were incompatible with the new machinery. The excess became inventory. The shortage remained unresolved. The quota had been met. The economy had not. On paper, both factories could defend their performance. Within the computational model, the misalignment was immediate. The system flagged redundancy in one region and bottleneck in another. It suggested rerouting copper supply. It proposed recalculating next quarter targets. It identified inefficiencies embedded not in effort, but in coordination. The computer did not criticize management. It processed inputs. But processing exposed structure. And structure implied responsibility. A planning apparatus built on paper summaries suddenly faced computational transparency. The machine did not only speed up the plan. It revealed where the plan depended on delay. The machine worked too well. Each ministry maintained its own data authority. Industrial, transport, agriculture, defense, all operated parallel information hierarchies. Control over data meant control over narrative. If OGAS centralized information flow, the political geography of the bureaucracy would change. Budget allocations were tied to reported output. Status depended on meeting targets. A shared network threatened that autonomy. Standardization reduces discretion. A ministry did not lose data. It lost leverage. Interministerial committees reviewed cost estimates. Some supported modernization. Others raised practical concerns. Telecommunications capacity was limited. Hardware production lagged behind projections. Training thousands of specialists would take years. These concerns were not fabricated. But they functioned as deceleration mechanisms. Funding approvals were staged. Pilot projects expanded slowly. Debates focused on technical feasibility rather than structural implication. Glashkov's team argued that without network integration, isolated computers would only digitize existing inefficiencies. Local automation without systemic coordination would reinforce fragmentation. The argument was mathematically coherent. But integration required surrender. Ministries would need to expose raw data. Adjustments would become traceable. Discrepancies would lose flexibility. The machine's success threatened negotiation space. The proposal was not rejected outright. It was reframed. Instead of a unified national network, smaller sector-specific systems were approved. Instead of central optimization, localized automation was encouraged. Computers were purchased. The network was deferred. By the mid-1970s, OGAS as a nationwide infrastructure had stalled. The machine had proven capable. The system had proven resistant. Inside laboratories, engineers recognized the pattern. The prototype had demonstrated feasibility. Simulations had validated optimization. Reports had documented potential efficiency gains. But structural integration required redistribution of authority. In a system built on controlled information flow, accelerated transparency is destabilizing. Quotas stabilize expectation. Delays stabilize hierarchy. Manual reporting stabilizes interpretation. Automated processing compresses all three. The machine did not overthrow planning. It compressed it. And compression removes space for negotiation. Over time, innovation recalibrated itself. Research institutes continued developing computing technology. But proposals aligned with existing administrative boundaries advanced more easily. Ambitious systemic redesign became less visible. Engineers learned to frame improvements as supportive, not transformative. Computers remained tools. They did not become architecture. The Soviet Union invested in hardware. It trained programmers. It produced machines compatible with global standards. But the national network envisioned by OGAS never materialized at scale. Years later, the consequences became structural. As digital networks expanded in other parts of the world, linking universities, research centers, and eventually commercial institutions, data began to move horizontally rather than vertically. Distributed systems allowed faster adaptation. Information flowed without waiting for administrative clearance. In contrast, the Soviet system remained segmented. Computers existed in factories. Terminals existed in ministries. But the connective tissue between them remained limited. Economic coordination continued to depend on hierarchical channels. The opportunity had not been technological. It had been structural. The calculations had been demonstrated. The improvement had been measurable. But integration required political concession. The machine had worked too well. It revealed inefficiency embedded in authority. And because it revealed too much, it remained partial. The room-sized computers continued humming. Punch cards continued feeding. Printouts continued emerging in steady lines. But the national network remained theoretical. A machine designed to strengthen the planned economy had demonstrated its limits. Not technological limits. Structural limits. Innovation was not banned. It was contained. And containment preserved stability. For a time, the system had not defeated the machine. It had defined its limits. Calculation remained possible. Integration did not. It was not a technical failure. The boundary was not technical. It was institutional.